Hey
Hello.
Nico. Hey,
Hello.
hey.
Hi.
How are you feeling after your situation?
I'm doing better. Instead of I just need to go over some of like the actual lessons because I'm so confused on some of the
Sure,
stuff. So
sure. Yeah. Are we waiting for Jamie or is that
uh I can check. Yeah, let me text him.
okay? I'd like to, I had prepared a few words last time, but I'd like to give them to you now, if that's okay. I got some feedback on like how the semester went for you, and what I felt like is that the WebAssign weren't really representative of what you got on your tests. And so I'm happy to do the WebAssign with you. We can always work through that stuff, but it seemed like if there were questions from class that either if we just did again and I gave you similar ones, or when you had a test review, like that might be the better course of action to help you in this class.
Okay, yeah.
So if that's ever an option, we can use the time however you want, but that's
Yeah.
fortunately, WebAssign, there's Pearson, there's a bunch of these other things. The schools just get them and they assign problems, and they may or may not match what you see on the actual test or quiz.
Yeah. Yeah. I think that's how it's gonna go today for me because like there's some examples from each of the like lessons that I just want to cover or like some ideas.
Absolutely. Yeah.
I'll send those over. Let me
Okay.
screenshot them.
Yeah, sounds good.
Hello.
Hey, Jamie. Nico's already in the
Sorry.
room. You probably could see that already.
Yeah.
So he mentioned there's some stuff he'd like to get caught up on. Are there
Yeah.
some things that you would like us to review? As always, just send them over by email or through the chat or however you want to get them to me.
Okay.
We'll work through them. So
I have a couple problems.
I'm just standing by here. Wait
Okay.
for whatever I see come in.
I just sent you some over.
All right, I'll take a look.
Mine's like uploading right now.
All right. All right. So any particular order on these examples?
No. I think like two of them are like with the same lesson, 4.3, and then 4.4. I just like need an example of like how to solve it and like
Sure.
what to do.
Yeah. Yeah. All right. So we'll start here. And Jamie, I'll get to your questions. Just mix them in here. Try and do them in a way where they're related. Okay, a person, if you're seeing my screen, a person is 200 yards from a river. Rather than walking directly to the river, the person walks 400 yards along a straight path to the river's edge. Okay, so I'm gonna take a small guess at what's actually going on. This is very, very weird. I guess the person is here, and instead of going this way, they walk towards the edge. And this is 400 yards. but they're actually 200 yards from the river. Does that picture work with this description? Can you follow that?
Yeah.
Okay, so it says find the acute angle between this path and the river's edge. So I believe it's looking for an angle right there. Is that okay?
Yeah.
Clear?
Yeah.
Okay. Now, one of the things I noticed about this particular problem, and I don't know if it's 4-point or not, but there's two special triangles that you got to know. One's 45, 45, 90, x, x root 2. Have you seen that before?
Yes, a little bit.
And then there's 30, 90. And so if this is 30 and this is 60 and this is x and this is 2x, this is x root 2, x root 3. So what I noticed right away here, and I obviously have a lot of experience here, but like these are related, these are double. And so like I'm immediately like, oh, this is a 30, 60, 90 triangle. Now we can find that out another way, but I'm guessing that's why this example is chosen. Okay, so what I mean is that if this is 30 and this is not drawn to scale, and this is 200, according to the 30, 60, 90 triangle, the hypotenuse, which is this right here, is double the short leg. This is the short leg. And the long leg is the short leg times the square root of 3. Now the angle is what they're asking for here. The angle is 30 because that's a known angle in this 30, 60, 90 triangle. Does that help here?
Yeah, it looks like we did it somewhere else where it was like using
We used
sine,
like the sine,
cosine, and
cosine.
tangent.
Yeah, so let's do it that way now, just so you guys can see this, because you know you don't want to just take my word for it. Let's do it another way. So let's say this is truly the picture, 400, 200, and we want angle A. So relative to angle A, this is opposite and this is the hypotenuse. So the cosine of A, I'm sorry, the sine of A is 200 over 400. And this is found out by either, you know, special right triangles or, you know, a sine inverse. The sine inverse of the sine of A is the sine inverse of 1/2, which ends up being 30. Is that okay? Is
Yeah.
that clear? Kind of? Okay. Let me download this picture, one picture that Jamie sent. Maybe there's one that's on here that's sort of related to this that we can do. The second. Which problem here? Was it 6 that you wanted us to look at?
Yeah. 6 should be good.
Okay. Yeah, let me let me grab that. All right, so it says assuming the Earth is a sphere with a radius of this, what is the latitude difference between these two places? Okay. Are you guys using S equals R theta, or was it that S
Oh,
equals
S
R theta?
equals R theta.
Is that correct, or was that just like something you wrote down?
That was what I should have used on that problem.
Okay,
That was a
so
good feature.
sorry. This is not related to that. let me come back to that. I
Okay.
saw the right triangle and I got excited that it was similar. So let
Oh,
me
yeah.
go back to Niko's set here.
No problem.
Yeah, let me do one more of these 4.3 problems and then we can jump to something like that. Sorry, this feels a little disjointed. I apologize. I'll try to
Oh, no, he's missed a lot. I understand.
yeah.
I don't have that many questions.
Yeah, skateboard ramp requires a rise of 1 foot for each 3 feet of horizontal length. So there, again, you need a picture here. I don't know if you guys do skateboarding or ever did, but it's saying this is 3, this is 1, and this is a right triangle. All right, find the lengths of sides B and C and the measure of theta if the height is 4 feet. So they're telling you like, this is like what it is, but in reality, it's actually 4 feet. So through similar triangles, if you multiply this side by 4, you have to multiply this side by 4 to get 12. Is that okay?
Yeah.
So the angle is actually the same whether you use this one or this one, but we'll talk about that maybe another time. So find the lengths of sides B and C. It doesn't really say what those are, and the measure of angle theta, the height is 4 feet. I don't know. Let's just do it for this one on the left here. So you've got in your toolbox a squared plus b squared equals c squared. So that squared plus that squared is square root of 10. If you do that over here, which we will do here, that's 144 plus 16. It's the square root of 160, which does reduce. It's 4 root 10. Okay. So now we can find things like, let's find the sine of theta in both. So on the left here, the sine of theta is 1 over the square root of 10. On the right here, it's 4 over 4 square root of 10, which, wouldn't you know, it reduces to 1 over the square root of 10. So if we actually wanted the angle, and it's not clear which one it is, it's the sine inverse of 1 over the square root of 10. Very important in this part of the course to make sure your mode in your calculator is in degrees. If you guys are taking a physics class, it's very easy to be switching in between that. The two options are degrees and radians. You want to make sure you're in degrees here for that. Okay, so let's just say we wanted the other angle. Well, if you've got one angle, to find the other angle, you just use 90 minus that. You could also do some trig stuff with it, but you generally only need to do it one time. So you'll notice like the angle doesn't matter whether you're using this one on the left or this one on the right there. Okay, so I'm going to jump back to Niko, unless you have any, is there any follow-up to this that you would like to ask?
No, I think I got it.
Think got it. Okay. Probably good for you to see this question here. I'm gonna snip it down. Jamie's question. Okay, so the Earth is a sphere. Yeah, that's true. So the idea is that let me try to draw this reasonable. So here's the Earth, and this is 6, 3, 7, 8, and so is this. This is 6, 3, 7, 8, and it's saying that one is 700 meters due north. So like one is here and the other is here. And they're saying that this is 700 between them.
Got it.
Like, and it could be that it's, there and there. We don't really know. But they want the angle basically. So you got it down. You've got the equation S equals R theta. Well, S is this distance. Like if you're walking, it's 700 kilometers. R is your radius. So theta is your angle. So it's 700.
Oh, so you just have to divide. Oh, shoot.
Yeah, it's not that complicated once you know how to do this. Now
Mhm.
this angle measure though is in radians. And that's one of the things that they don't tell you. They don't tell you that this is in radians, theta and
Mhm.
radians. And until you've worked through this before a few times, you just don't, it doesn't really make sense or matter. But because the answer here, they want it in DMS form,
Yeah,
right? And we're not talking about direct messages,
degrees and seconds. Yeah.
minutes and seconds. Yeah. So that could also be a little bit awkward if you haven't done this before. So this 700 over 6378, we got to get that as a number. And then the very first thing you do is you convert it to degrees. So to do that, you multiply by 180 over pi. That's to get the degree part. So I'm gonna get that number for you guys because then we got to kind of chop it up after this. So it's 700 over 6378 times 180 over pi. All right. So I get, let me go, I get 6.2883 and it keeps going. Is that what you guys, is that what you guys got it? Okay,
Yeah.
so you can say for sure it's 6 degrees. So what you do is you chop that part off and then you take this decimal, okay? And if just the simple way to do it is just whatever number you got in your calculator, you subtract 6 from it. So you just, that leaves just the decimal part. That decimal part you multiply by 60 to get the minutes.
Oh, shoot. Got it.
Okay, so this is kind of a pure manipulation of the calculator numbers. There is maybe a conversion inside there. I don't actually know. So this ends up being 17.301. So that's 17 minutes. So then you chop off that 17
And 60 again.
and you multiply by 60 again. Yes, it's very, very repetitive. And then you take that number, like you said, you multiply by 60, and usually you stop there.
Mhm.
18 seconds.
Got it.
So I think when we used to travel the world by boats, this was important. I don't think they do. They might use this in space travel, but I doubt it. I'm assuming this was a very archaic way of doing it. I don't think there's anything doing it now. So that's how this question is made more difficult. Kind of for your honors class, like S equals R theta is pretty straightforward, but when you have to convert it, or if they give you the angle and this and you have to convert it to radians, that's step, so to speak, for that.
Hmm. Okay. That makes sense.
This question, are you guys, let me really quickly search this question because this looks like a question I've seen before, and it might help give us some insight. Yeah. Okay. So this question is a Quizlet question.
Oh, really?
And yeah, and like teachers, they have a lot that they have to do. Your instructor is grabbing this question from somewhere else, and that gives us some insight into like where the questions are coming from sometimes.
Mhm.
Let me look here. Let me send this to you. Let me send it to everyone. This looks pretty close to what you guys have been doing. I'll just send this in the chat, and you guys can take a look at it an hour later and see if maybe it's similar to that. And all we're trying to do here is figure out where your instructor might be getting questions from, or
Mhm.
to help you kind of see if there's get some insight into what they're doing. All right, so Niko, we'll jump back to you. You got this second question here, 4.3. Let me grab this last 4.3 notes, and I'll try to explain this real quick. This is, so there's like in trigonometry, there's a bunch of formulas, and this is just one of, I'll say, 90 formulas for this class. But the way it's done, it would be like sine of 32 degrees equals the cosine of what angle? And to do that, you got to figure out, well, which of these identities do I use? Now, you'll notice that sine and cosine are paired together. Cosecant and secant are paired together, and tangent and cotangent are paired together. So once you realize that, you say, oh, they're all kind of the same. This is really cosine of 90 minus 32, which is the cosine of 58. So if you were to put in your calculator the sine of 32, it is the same as the cosine of 58. So Jamie, last week we were graphing sine and cosine. You remember that?
Yep.
And I said, well, they're actually the same. And
Mhm.
what, like in it's because of this. If you just remember how if we just shifted the cosine over, we got the sine.
Yeah, it was like translating.
That's what this is telling you. So all of
Got it.
these trig functions are just shifted from one another.
Mm.
So you'll get a question. It won't be in this form though. And maybe let me go back and look at that one I just sent you guys. No, there's nothing on here like that. Like it might ask you something like this, like what is the sine squared of 32 plus the, no, I don't know what, I don't know how they would use this as a question. So I won't be able to help with that. All right. Have you guys been asked to do a unit circle, like a quiz where you have to write out the
Yeah.
entire unit circle?
Yeah, we had a memorization quiz for the unit circle.
Niko, did you take that? And if not, how's it?
No, I was sick. I missed
Okay.
that one.
Do
But
you know
I've
what
done the unit circle. Like I was
you
there for
know
the
what I'm
lesson.
talking about? Okay. So this is another reference. This is a reference sheet I'm going to send you guys in the chat. I really like this one. I still use it to this day. It's got everything you need in trig, which is why sometimes this class is in college. Sometimes they teach it in like a reduced amount of weeks because it's not really a full class. But like this next section here, you are supposed to be able to evaluate something like what is the cosine of 120 without the unit circle. And I guess I want to give you at least an example or two of how to do that. So 120 is somewhere over here in the second quadrant. And the reference angle is 60. So like to do any of these problems, there's a recipe here. And the thing is that it's the cosine or the sine of any angle, sine, secant, cosecant, like whatever they ask you, it is always the same thing, the cosine, the sine, the secant, the cosecant, the cotangent, all of that of the reference angle, but it's either positive or negative. And if that isn't like, if what I said didn't make any sense, you should notice a pattern on the unit circle. You should notice that like there's only so many answers and they're just positive and negative of one another. Okay, so like you might say, hey, Matthew, I got my unit circle out. I know that that's negative 1/2. And I'm gonna say you're right. But it's also the cosine of 120 is also equal to plus or minus the cosine of 60, because that's the reference angle. And then how do we figure this plus or minus out? That comes from the following. ASTC. So have you seen that before?
No, not the
Mm-mm.
ASTC.
Okay, so this stands for all students take
Oh, take
calculus,
calculus.
which is not true, but we're gonna go with it for this. What is true is that where A is in the first quadrant, and that means all of your trig functions are positive. They're all positive. S here means that only sine is positive. So if sine is positive, that means cosine is negative and tangent is negative. This quadrant where it's T in the third quadrant, that means tangent is positive, but sine and cosine are negative. So the letter tells you which one is positive. So in the fourth quadrant, cosine is positive, but sine and tangent are negative. Now you might think, okay, well, that's great, Matthew, but what about like secant? Well, secant is really 1/cosine, right? So if I ask you about secant, I'm really asking about cosine, and that maps to this thing right here. So you definitely want to be able to remember this. It is super helpful. So getting back to this, well, how do we figure out whether cosine of 120 is positive or negative? Well, cosine of 120 is in the second quadrant here. So is cosine positive or negative in the second quadrant? It's negative because only sine is positive. So this equals the negative of the cosine of 60. So the power of this, and I know it's a little scrambled here. The power of this is that you can actually only learn the first quadrant of the unit circle if you know how to find the reference angle and you remember ASTC, because it tells you whether it's positive or negative. Okay, so let's do another example here. Okay, a more realistic one. What is the tangent of minus 7 pi over 6? Okay, and at a test you might get like, this would be like A through D, you get a bunch of these. So where is minus 7 pi over 6? Well, on your unit circle, oh, that's really bad. On your unit circle here, normally you go this way, that's positive, but you can also go this way for negative. So 7 pi over 6 is actually over here if you're going this way, negative, going clockwise, I guess. I don't know why they decided that, but that's what it is. So the reference angle is the angle made with the x-axis. The reference angle is always the angle made with the x-axis. So in this case, it's pi over 6. So this is equal to plus or minus the tangent of pi over 6. Now, if you remember that ASTC, okay, so in the second quadrant here, sine is positive, but everything else is negative. So this is equal to the negative of the tangent of pi over 6. And then you're supposed to know, okay, tangent is sine pi over 6 over cosine pi over 6. Maybe you even visualize where that is on the unit circle. That's this first one here, where it's a 1/2 comma root 3. I'm sorry, it's root 3 over 2 comma 1/2. And then you can map those values in here. So that's that, like if you can do all that, like then you truly understand what this 4.4 thing is telling you to do. So this is negative 1/2 over square root of 3 over 2. Okay, x, for a reminder, x is always cosine, y is always sine. Okay, so this becomes negative 1 over square root of 3. And then you rationalize multiplying the top and bottom by the square root of 3. So it's negative square root of 3 over 3. Jamie, you've been in class. I mean, is this kind of thing you've been doing, or
Yeah.
am I way off here?
No, this is like the same.
Okay. Do you guys want to do more of these? Because I can
Yeah,
either
can
ask
like
you to do
another
more.
example, I
Yeah.
think. I'm still a little confused.
Yeah. So Jamie, since you're a little bit more of an expert at this, will you help me with this next one? So let's do the cosecant of 5 pi over 3. Okay. So I've said this a few times. We got to find the reference angle. So where can you tell me which quadrant 5 pi over 3 is? It's okay if you need to look at the unit circle, but you eventually want to do it without that.
The fourth one, right?
Yeah, because if you go, it's normally 0 pi, but whenever you have a denominator that's not nice, you can make this 3 pi over 3. And then this is normally 3 pi over 2, but like, okay, that doesn't make a lot of sense here in this context. This is actually 1.5 pi over 2 over 3, which reduces to pi over 2. And then notice you're just jumping by 1.5, 1.5, and then 1.5 to get 4.5 pi over 3. And then where's 5 pi? Well, it's here. It's here. It's going this way. So you're in, like you said, it's in the fourth quadrant there. The reference angle, the angle we want here is the angle that's made with the x-axis. So what do you have to add to get back to 0 here? And and the help here, the hint is that it's the same as this angle here.
You want
Pi over 3. it like pi over, like if
Mhm.
you go back pi over 3, you get to here. Do you agree with that? Do you see that?
Yeah.
Okay. So now we got to decide, is it positive or negative? That's where this ASTC thing comes in. So in the fourth quadrant, C is not cosecant. Cosecant is more like sine. Is sine
Mhm.
positive or negative in the fourth quadrant?
Negative.
Cosine, it's negative. So this, so we say, no, it's negative. So this is negative cosecant pi over 3. So this is really, it's -1 over sine pi over 3. So if you know your unit circle, that's the one up here. That's the one that's 1/2 comma root 3 over 2. Sine is the y value. What's the y value here?
Square root of 3 over 2.
Square root of 3 over 2. And this becomes -2 over the square root of 3. And then you have to multiply by square root of 3 to rationalize. Now, if you're wondering why this is useful, like this itself is not useful. Like the actual calculation of this is, I mean, you're never going to be asked to do this in a job or anything like that. But if you do take more math, trigonometry is the basis of that. So in your calculus, you'll see it, your calculus 2, physics, any sort of applied engineering science, you will see this stuff again. So that's why you have to learn it if you want to take those classes. So like the stepping stones are here, like just so you know, Niko, like the sort of the starter questions are like, what is the sine of 30 degrees? And then then you move up to like, what's the tangent of 135 degrees? And then you start moving up to, okay, what's the cosecant of 5 pi over 4? And these you're just ramping up in your difficulty on these. So like some of them you just read off the unit circle. Some of them you combine values in the unit circle, and others you really need to be able to manipulate them the way we just did in a couple of examples.
Okay, yeah.
All right, so let me Jamie, work on that WebAssign question. So you guys familiar with Chegg? You heard of Chegg before?
No.
Okay. Well, Chegg has the solutions to almost all of these questions. And now that I have a better understanding that your class doesn't really use these, you may consider getting a Chegg account each other, or maybe you've already one. The reason is because like these questions just aren't showing up on your test. So you just want to know how to do them to get the right answer and be done with this. So
Yeah.
it says, what is the period of each function? You got that down. That's great. You did 2 pi over pi over 6, because that's the number on a t. That's how you got your 12. That's awesome. Okay, what part of the year is the difference between the normal and high temperatures greatest? When is it small? So unfortunately, I'm gonna have to graph these things to find the answer to that. I'd like to do that for you guys. I think that'll also help with part C. Let me get set up to where I can do that, and then I'll jump over to there. Okay.
Okay.
So Niko, last time with Jamie, we did some work in Desmos. I think it's a great tool. I use it for a lot of things. It's way better than your graphing calculator. So all right, so we're doing the high and the low. So 54.33 minus 20.38 times cosine. Actually, you don't even need to put cosine pi. Now they like X instead of T. So you minus 15.69 pi X over 6. Okay. Now, one thing you probably noticed right away, Jamie, is like, can't see this at all. So you can zoom out, but you can also tool thing over here. Now our period is going to be 0 to 12, but for some reason it's not liking that. Why is that? Let's get that in a moment. Okay, let's do our y-axis. So your y, I don't know, I'm just going to go minus 100 to 100 and see if that does anything. That looks okay. Right. So what's nice is with Desmos, you can actually just click and it gives you kind of these points that you care about. So now to find the difference, we have to subtract out the other one. So I'm going to put it in parentheses. That way I don't have to worry about combining like terms, like let the calculator do the hard work for you. Pi x over 6 minus 14.16 sine pi x over 6. Okay. So now it literally is graphing the difference between them.
Oh, wow.
So you said, so when is the difference the smallest? So you said in December. So that's x equals 12. So it's the smallest because it's right there. I guess that's minus 88.
Mhm.
And then the greatest, I mean, it looks like it's there at January.
That's what I was
Maybe it
thinking.
doesn't, maybe it doesn't start January. Huh. Oh, t equals 1 corresponds to January. Do you see that? T equals 1
Mm,
is January. So
shoot,
that's not,
that's not January.
that's,
That's like
it's like
December.
December, smallest. So maybe they mean no, maybe they mean, I don't know. um wow, I'm not feeling good about this question at the moment.
Mm. Yeah, it
Greatest
just confused me.
normal low. So the greatest, like to me, the greatest is there at 0. And then that's, but if it starts at t equals 1, yeah, I don't have a good answer for you on that.
Okay.
Okay, now the sun, the warmest temperature just, so the nice things here is you can copy and paste. So I'm gonna do that here. And the reason that's useful is can move out the second part that's not useful for the for that. So the high here is right at 4.322.
Mhm.
The sun is farthest from the sky around June 21st, but the graph shows the warmest temperature at a later date approximately how many days after June 21st. So 4.322. So that's that's not coinciding. Did I not? I don't know. Did I not graph this right? 20.38.
Oh, might be missing a cosine on the bottom.
Yes, it is. And that's why it didn't work. That's why the southern one was off. Thank you. Thank you. There it is. Okay. Now we can answer this. All right, let's go to that first question. So it's right there that it's
Oh,
greatest. Okay, so month 5. So if you know, sometimes you gotta get the fingers out here and count by fingers, but 1 is
mhm.
January. So then 5, 2 is March, or 2 is February, 3 is March, 4 is April, 5 is May. So it looks like
May.
May is the greatest,
Mhm.
I guess.
Yeah, that was right.
Okay, now this last part refers to it's asking what's the warmest temperature, which I think is just the green. So that's at 6, and 6 is June. Hmm. Hmm. Is that right? June 1st?
Let me see.
Yeah. at a later date. I don't know. I don't think it shows that at all. Yeah, I'm not sure. So let's move. I'm going to move away from this and let's go back to working on some stuff here. Niko, do you have any other questions that you would like answered? Otherwise, we can just do some more review.
Yeah, I'm gonna send you another like lesson part.
And Jamie, same thing. If you got another question there or another, kind of a quiz thing, we could also look at.
Okay, I'll take a look.
Okay, I sent over. They're both like together. It's just like it needed 2 slides to kind of explain.
Sure.
Can you just kind of? I'm just kind of confused on what that means. I tried like
Yeah.
looking into it. It just does not make sense.
Yeah, of course. Usually the first time we see stuff, it just doesn't make any sense.
Yeah.
And yeah. So let me make a graph here and we'll just go backwards so you guys can kind of see like what's going on here with this. Let's go. All right, so I'm going to snip in a graph here and we'll try to do this the way you'll probably see it on an exam. Actually, you need one more point to do this. I think. Couple of types of problems you'll see. One is they give you the equation and you have to graph it from there. They give you the equation if you make a graph. And the other one is they give you the graph and you have to make the equation. So there's a couple of characteristics of the graph that you care about. One is the center line. The center line is literally where it's the center. So if you can't tell, and sometimes it's hard to tell depending on the quality of the graph they use. The center line's at 14. Do you see that?
Yeah.
Mhm.
Okay. So then Niko, you said, well, hey, like what's going on here? So here's the equations they give you. Let me snip those in as well. They're very much center line is D in both cases. Okay, now you can find that in another way. So like I didn't give you the peak. The peak here is at what is that? 6, what did I graph here? Go back and get the graph. 6, 17. So the way you find the center line or this D value, D is equal to the average of the min and the max. So it's 11 plus 17 over 2. But in words, it's the average of the peak and the valley. Is that okay?
Yeah.
Now this A is a little bit different. It's the distance. It's the distance from the center line to the peak or the distance to the valley. And it's really similar. So in this case, you can see that it's 3, but it's done slightly differently. You do it as 17 minus 11 over 2, which ends up being 3. So the more general way of doing this is that D is the max plus the min over 2, and A is the max minus the min over 2. And they're really similar, really similar. So it's easy to mess them up. Niko, did that maybe answer what you had
Yeah,
a question about? Okay.
perfect.
All right. Oh, and it looks like your instructor is using Desmos. The value of A also depends, and that's why they write absolute value, is because the value of A also depends on whether it opens up or down and so on. But we probably can't get to all that now. Jamie, do you have a quick question you can send over or not on that?
Not really.
Not really. Okay. All right. Let me see. Got that. Okay, so let's go back to these equations real quick, because these are important here. This is kind of review from last time for Jamie as well. So sometimes the equations are written like this: a sine b x minus c over b plus d. And your period is always, it's always 2 pi over b. But your phase shift is the c over b. And if you recall, you need both of those for graphing. D is your center line. We just talked about that. And the absolute value of A is your amplitude. If A is positive, that's kind of the normal case. But if A is negative, it's a flip.
Mm.
So a question you will see if you haven't seen it already is they will give you a graph like the one I just presented up here. And they might say to graph, or they might say, you know, write this in terms of sine and then write this in terms of cosine. Okay, so since I already know which one I graphed, we'll do the easier one first. This is a sine. The reason it's a sine is because it starts at the center line, but it goes down. So that means if we're doing this a sine bx minus c plus d, and we found A is this distance here, that's 3. It's -3 though, because it's going down. The period is 2 pi over b. Okay, but we don't know b, but we're given the period. The period is peak to peak, or it's valley to valley. And you can see valley to valley is 10 minus 2, which is 8. So A equals 2 pi over b. When you solve for b, it's pi over 4. So that goes here. There is no phase shift because it starts right there. And then the vertical shift is 14. And so a really difficult instructor would also ask for this in terms of cosine. They would also want to know, well, what is it in terms of cosine? Some of it's the same, but some of it's not the same. Unfortunately, we don't have time to go through all that, but that's what you could expect on a test or quiz, something like that.
Okay, perfect.
Great use of your time tonight, guys. I always look forward to helping you. I'll send you the notes here shortly, and I'll see you next time.
Okay.
Thank you.
Thank
Have a
you.
great night. Bye now. You're welcome.
You too.
Bye.